Algebra 1 EOC practice test number 27. Consider the equation 3 times x minus 5 squared plus 6 equals 54. What values of x make the equation true? Enter one solution in each space on the answer document. If there's only one solution, leave one blank. Alright, so let's look at what we have. We have a quadratic equation. So if we start, we can solve that by just trying to get x by itself. So to do that, to solve this equation, we're going to first subtract 6. Remember, when we're solving, we're kind of undoing the order of operations, so it's kind of like we go backwards. So we're going to subtract first, and then 54 minus 6 is 48. Then we're going to divide after that. So we're going to have x minus 5 squared equals, 3 goes into 4 one time, 1 left over, 3 goes into 18 6 times. All right, now from here, something squared means we have to square root it. Once the squared term is isolated, means all this other stuff was taken care of first. Now we can undo the squared term by doing the square root. Now remember, the square root cancels a squared term, but we also had a variable here, so we have to put a plus or minus, and so we have plus or minus, and the square root of 16 is 4. So that means there's going to be two solutions. So I'm going to come over here to the left, so we're going to have x minus 5 equals positive 4. And then we're going to have x minus 5 equals, plus or minus means we also have a negative 4. So add 5. All right, so we're going to have x equals 9. So that's one solution. And then we're going to have plus 5, negative 4 plus 5 is 1. So that's our second solution, x equals 1. Now, if you want to check this using a different method, you could always plug this in your calculator and graph it. So let's use the calculator here. And I'm going to, I'm going to graph this equation here, but I can't just subtract 54 and set it equal to 0 to find the zeros, because you have to take into account this whole side would have to be adding 54. So not just the 6 in this case. So let's go ahead and look at how we set it up with two separate equations, which we have done as well. So we're going to put the left side in as equation 1. So we're going to do 3 times x minus 5 squared, and then plus 6. And then I'm going to scroll down, and I'm going to put 54 in as my second equation, and I'm going to hit graph. All right, so right now I can't see both sides, but when I know this is 54, y equals 54, this is my y-axis, I'm going to change this window to make sure my y maximum goes up past 54. So I'm going to change this to 60. 60 is greater than 54. So now when I hit graph, my window should show me both graphs. All right, now you can see here we found our solutions to be 1 and 9. So it kind of looks like 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Kind of looks like 9 there as well. But you could always do second trace and find the intersection values. So if you hit 5, okay, we've got x at 0. All right, you can see the cursor there. It's right before 1, so I'm going to hit enter. Then I'm going to scroll down. I'm going to hit enter again. And it's going to tell me that the intersection is 1 and 54. So that confirms that the 1 is correct. And then we're going to do the same thing over here. If you want, you probably could scroll across since that's a horizontal line. It should say when you get to 9 and 54, it's very close there. Let's go ahead and do the intersection point just to make sure. 5 is intersect, and we are going to go to the other side of the graph. Now we're looking for this intersection point, so we're going to hit enter. We're going to go to the other side of it. We're going to hit enter again, and it's going to give us 954. So that does confirm that these are our two solutions. So there's two ways to find the answer. It says what values of x make the equation true. X equals 9 and x equals 1.